January 1945. Night hangs low over the Japanese home islands. In a coastal command post, officers lean over dimly lit maps. Radios hiss softly. Antennae sway outside in the winter wind. There is no moon, no visibility. The sky should offer protection tonight. Then the first reports arrive. Explosions. Precise. Unmistakably deliberate. Bombs are falling not in wide patterns, but with an accuracy that feels intentional, almost guided. Industrial blocks ignite. Rail yards vanish in smoke. A refinery, thought hidden by darkness and cloud, erupts exactly where the signal originated. Japanese officers exchange looks they do not voice aloud. Pilots had reported Allied aircraft nowhere near visual range. Spotters saw nothing, yet the bombs arrived as if pulled by an invisible thread. Someone adjusts the radio frequency. The signal strengthens. Minutes later, another strike lands closer. In after-action reports, a chilling phrase begins to appear again and again. The bombing followed the radio. For the first time, distance, darkness, and weather no longer feel like defenses. The war has learned how to listen, and that realization leads directly into how the world arrived at this moment. When the Pacific War began in December 1941, air power was still constrained by the limits of human sight. Bombers navigated by coastlines, rivers, stars, and dead reckoning. Crews relied on maps, stopwatches, and visual markers scratched into memory. Cloud cover, storms, or nightfall could turn a mission into guesswork. Even the most disciplined air forces accepted wide margins of error as unavoidable. Japanese military planners understood this well. Imperial Japanese doctrine emphasized distance and environment as natural shields. The vastness of the Pacific, the volatility of weather, and the complexity of island chains were not obstacles. They were strategic assets. Darkness, in particular, was trusted. At night, enemy bombers would struggle to find their targets. In bad weather, they would turn back. Early Allied bombing appeared to confirm this belief. In 1942 and early 1943, U.S. Army Air Forces operating from distant island bases faced enormous challenges. Missions against Japanese-held territory often ended with scattered bomb patterns, inaccurate results, and heavy fuel losses. Visual bombing over jungle, ocean, or cloud-covered cities produced limited damage. Many bombs fell into empty terrain or water. Japanese after-action assessments reflected cautious confidence. Reports noted Allied inaccuracy. Night raids are described as harassing rather than decisive. Radar coverage around key installations was limited but considered sufficient because bombing without sight was believed inherently unreliable. This belief shaped Japanese command behavior. Factories were dispersed but not deeply concealed. Critical infrastructure, rail hubs, oil storage, power stations, was camouflaged visually, not electronically. Radio discipline focused on communication efficiency, not emissions control. Signals were transmitted confidently, assuming the enemy could not exploit them in real time. Meanwhile, Allied air commanders were drawing different conclusions. In Europe, the air war over Germany had already exposed the limitations of daylight visual bombing. Losses were severe. Accuracy depended on weather. Clouds over targets meant aborts or scattered payloads. The solution emerging from British and American laboratories was not better eyesight, but invisible guidance. Radio waves. By 1943, Allied engineers were refining systems that could navigate aircraft across oceans, identify coastlines, and even guide bomb release, without a single visual reference. What had begun as navigation aids were becoming targeting tools. In the Pacific, this shift was urgent. Japanese-held islands were often small, isolated, and heavily defended. Approaching them visually meant flying directly into anti-aircraft fire. Weather conditions across the Pacific, monsoons, typhoons, heavy cloud banks, frequently canceled missions. If the war was to be won from the air, bombing had to become independent of sight. The Japanese High Command did not yet fully grasp this transformation. They monitored Allied aircraft numbers, base construction, and production figures. But the quieter war, happening in radio labs, engineering units, and electronics workshops, received far less attention. Signals were still considered passive tools. They had not yet become weapons. And that misunderstanding would soon collide with a new reality taking shape beyond the horizon. By mid-1943, the nature of Allied air warfare was changing faster than Japanese intelligence could track. Across the United States, Britain, and their Pacific bases, a quiet technological shift was underway. Bombers were no longer being designed merely to fly farther or carry heavier payloads. They were being taught how to navigate by signal, not by sight. One of the most significant developments was the refinement of radio navigation systems. Long-range navigation, known as LORAN, allowed aircraft to determine position by measuring the time delay between radio pulses transmitted from fixed stations. Over open ocean, where visual landmarks were useless, LORAN gave crews a reliable fix, even in darkness or cloud. For bombing itself, airborne radar became decisive. Systems such as the /APQ series enabled bombardiers to identify coastlines, rivers, urban concentrations, and industrial zones from altitude, regardless of visibility. On radar screens, cities appeared as bright, irregular masses. Rail yards showed as linear signatures. Oil storage tanks reflected clean, sharp returns. In Europe, these systems had already proven their value during overcast raids on German targets. In the Pacific, they offered something even more valuable: predictability over vast distances. To the Japanese, this was largely invisible. Captured documents and post-war interrogations would later show that Japanese officers often attributed improved bombing accuracy to luck or increased crew experience. The idea that bombs could be guided by radio emissions, by signals originating from the ground itself, was slow to take hold. But Allied planners were thinking exactly that way. Pathfinder units were formed to fly ahead of main bomber streams, using radio beacons and radar markers to designate targets. In some cases, ground-based transmitters, either friendly or captured, were used as reference points. In others, Japanese radio traffic itself became a navigational aid, unintentionally revealing locations and patterns. This was not science fiction. It was exploitation. Every active transmitter created a signature. Every consistent signal provided a reference. And as bombing systems improved, the line between navigation and targeting blurred. By late 1944, American bombers operating from the Marianas, particularly B-29 Superfortresses, were routinely flying missions in which visual confirmation of targets was unnecessary. Bomb release could be calculated, corrected, and executed using radar overlays and signal alignment. Japanese air defenses struggled to respond. Interceptors relied on visual detection and limited radar coverage. Anti-aircraft units depended on predicted approach routes. But aircraft guided by radio did not need to follow predictable paths. They could approach from altitude, from cloud, from darkness. Most unsettling of all was the growing pattern reported by Japanese commanders: bombing raids that seemed to respond to changes in radio activity. Command posts that increased transmissions during alerts sometimes experienced intensified strikes shortly afterward. Facilities that remained silent were hit less frequently. At first, this was dismissed as coincidence. But coincidences began to accumulate. In reports circulated within the Imperial Japanese Army and Navy, a new concern emerged. Not loudly, not officially, but persistently. Enemy bombing accuracy appears linked to radio conditions. The war was no longer only being fought in the air and on the ground. It was being fought in the electromagnetic space between them. And within that space, fear was beginning to take shape. 4 Japanese officers tasked with defending cities, bases, and industrial zones. The war had always been about prediction. They calculated likely approach routes. They tracked weather patterns. They scheduled blackouts and dispersals based on expected enemy behavior. Command rooms were orderly places, maps pinned with careful precision, clocks synchronized, radios tuned to known frequencies. Radio traffic was constant. Orders flowed from regional commands to air defense units. Status reports came back in clipped, formal language. These signals were lifelines, essential for coordination, reassurance, and control. But by late 1944, a subtle unease crept into these rooms. Officers noticed patterns they could not explain. Bombs fell with disturbing accuracy during poor weather. Night raids struck targets that had not been visually marked. Facilities thought secondary were hit first, as if selected deliberately. After each raid, the same question returned. How do they find us? Junior officers hesitated to voice it. Senior commanders resisted the implication. To suggest that their own signals might be betraying them felt dangerously close to admitting loss of control. Yet the fear was human, immediate, and deeply personal. Men trained to command by voice and wire now wondered whether speaking into a microphone invited destruction. Radios, once symbols of modern authority, began to feel exposed, almost dangerous. Silence, for the first time, seemed safer than communication, and that hesitation would ripple into tactics on the ground. Angle 2. The technological perspective when signals became guides. From the Allied side, there was no mysticism to it. Radio waves obeyed physics. Radar reflected energy. Navigation systems measured time and distance with mathematical precision. What looked like bombs following signals was the product of layered engineering. Airborne radar allowed bombardiers to lock onto urban density. Radio navigation fixed position across thousands of miles. Electronic intelligence units monitored Japanese transmissions, mapping their patterns and locations. This did not mean bombs homed directly onto radios like magnets. It meant something more unsettling. Radioactivity removed uncertainty. When a signal was present, it provided orientation. It confirmed location. It reduced guesswork. In war, reduced uncertainty meant increased lethality. As Allied crews trained on these systems, confidence grew. Missions once canceled due to cloud now proceeded. Targets once considered difficult were added to schedules. The battlefield was becoming measurable, and that measurement favored the side that understood it best. Angle 3. The tactical perspective. Night and weather lose their power. For decades, darkness had been a shield. Armies moved at night to avoid air attack. Facilities relied on cloud cover and storms as natural camouflage. Japanese defense doctrine assumed this would remain true. Radio-guided bombing shattered that assumption. With radar and navigation aids, bombers could approach unseen, release payloads accurately, and withdraw before defenses fully reacted. Anti-aircraft fire, aimed by sound or prediction, often lagged behind reality. The tactical balance shifted quietly but decisively. Where once the enemy had to see to strike, now they only had to listen. And for Japanese defenders, that realization was only beginning to take shape. As reports accumulated, Japanese commanders attempted to respond, but they were fighting something they could not clearly define. Initial countermeasures focused on familiar solutions. Anti-aircraft batteries were reinforced. Fighter patrols were expanded. Radar stations were ordered to improve detection ranges. None of this addressed the underlying problem. The threat was not where the bombers were. It was how they knew where to go. Some officers proposed stricter radio discipline. Transmissions were shortened. Frequencies were changed more often. In a few sectors, silence was enforced during air alerts. But this created new problems. Units lost coordination. Interceptors launched late. Ground defenses fired blindly. Worse still, the results were inconsistent. Silence did not guarantee safety. Reduced radio traffic sometimes coincided with fewer strikes, but other times bombs still fell with precision. This deepened confusion. If signals were not the sole cause, then what was? The answer, that radar bombing and radio navigation worked independently of Japanese transmissions, was slow to penetrate. To many officers, the idea that enemy aircraft could map cities through cloud using invisible waves remained difficult to accept. The enemy seemed to possess a sense beyond human perception, and that belief itself became a psychological vulnerability. Angle 5. The psychological impact. Fear of being heard. War had always produced fear, but this was a different kind. It was not fear of aircraft engines or falling bombs. It was fear of attention. Japanese officers began to speak quietly around radios. Operators hesitated before transmitting routine updates. Some units delayed reports, hoping to avoid drawing notice. In diaries and post-war interviews, veterans described a growing sense that the enemy was listening, not just to conversations, but to existence itself. If a facility functioned, if it communicated, if it emitted energy, it could be found. This eroded confidence. Commanders were trained to act decisively, to issue orders, to maintain control. Now, control itself felt exposed. Every transmission was a risk calculation. The battlefield had expanded into the unseen. And in that unseen space, certainty was gone. Angle 6. The strategic meaning. Precision as power. For Allied planners, radio-guided bombing represented more than accuracy. It meant tempo. Raids could be scheduled regardless of weather. Night operations reduced losses. Targets could be struck repeatedly, systematically, without warning. The enemy's defensive rhythm was disrupted. This was not just about destroying factories or rail lines. It was about undermining the belief that anything could be hidden. Precision created inevitability. And as this method matured, it set the stage for a moment when doubt would turn into realization. When Japanese officers would no longer question whether bombs followed signals, but accept that they did. That moment was approaching. By early 1945, the pattern could no longer be dismissed. From bases in the Mariana Islands, Saipan, Tinian, and Guam, American B-29 superfortresses were flying deeper, farther, and more predictably than ever before. The distances were enormous. The weather over Japan was often hostile. Yet the raids came on schedule, and they struck with intent. On certain nights, Japanese air defense logs recorded a disturbing sequence. Radio traffic increased as alerts were issued. Command posts coordinated fighter responses. Coastal radar stations transmitted updates inland. Then the bombs arrived. Not scattered, not delayed, but concentrated, falling on communication hubs, power stations, rail junctions, and industrial districts tied directly to command and control functions. In Tokyo, Nagoya, Osaka, and Kobe, officers compared notes. Similar reports surfaced from regional headquarters and naval districts. In several cases, strikes occurred despite complete cloud cover, with no visual sightings from ground observers until explosions began. One officer described the experience as being struck by something that already knew where you were. What made this moment decisive was confirmation. Captured fragments of unexploded ordnance were examined. Radar operators noted bomb patterns aligned with known urban radar returns. Intelligence officers reviewing Allied tactics recognized that the enemy no longer needed to see Japan to hit it. The realization spread unevenly but steadily. The bombs were guided before the aircraft ever arrived. Radio navigation had removed chance. Radar bombing had removed concealment. Together, they had removed safety. Attempts to mask emissions intensified. Some command posts relocated. Others reduced transmission power. But the infrastructure of a modern state could not simply fall silent. Railways ran. Factories operated. Power flowed. Signals existed. And where signals existed, orientation followed. 4 Japanese officers trained to believe that night, distance, and weather were allies. This was not merely a tactical defeat. It was the collapse of an assumption that had shaped the entire defensive posture of the home islands. The enemy had learned how to strike without asking permission from the sky, and the war would never feel the same again. As the air campaign intensified, Japanese headquarters began to receive a different kind of report, not from the front lines, but from analysts and investigators. Patterns were undeniable. Bomb damage maps showed correlations between strike accuracy and known urban signatures rather than visual landmarks. Facilities that had never been marked by flares or Pathfinder aircraft were hit with mathematical regularity. Raids conducted in complete darkness mirrored those flown in clear daylight. In some cases, timing itself was revealing. After a spike in radio coordination during air alerts, subsequent waves struck with adjusted precision, as if the enemy had refined its orientation mid-operation. Whether through navigation fixes, radar recalibration, or signal exploitation, the effect felt personal. Japanese officers were not imagining guidance. They were experiencing loss of uncertainty. This was the moment fear crystallized. The concept that bombs might follow radio signals was not technically precise, but emotionally accurate. It captured the sense that communication itself had become dangerous, that speaking, transmitting, existing electronically invited attention. Efforts to counter this came too late. Japan lacked the industrial capacity to rapidly deploy advanced electronic countermeasures. Radar coverage remained fragmented. Fighter interception was increasingly ineffective against high-altitude, night-flying bombers. Civil defense measures could not compensate for systematic destruction. Most critically, the strategic initiative was gone. Allied commanders now chose when and where to strike, independent of Japanese readiness. Weather forecasts mattered more to attackers than defenders. Darkness no longer delayed operations. The air war had become asymmetrical. For Japanese officers watching cities burn, the terror was not only physical, it was conceptual. The battlefield was no longer bounded by sight, sound, or distance. It extended into an invisible domain where the enemy operated freely. Signals that once symbolized command now symbolized exposure. By the spring of 1945, the conclusion was unavoidable. Modern war had learned how to listen, calculate, and arrive unannounced. And with that realization, the decisive phase ended, not in a single explosion, but in the quiet acceptance that control had been lost. The smoke that followed marked the beginning of consequences. As weeks passed, the long-term consequences of signal-guided warfare became impossible to separate from Japan's broader collapse. Defensive doctrine began to fracture. Orders circulated urging stricter radio discipline. Enforcement varied. Some units reduced transmissions to the point of paralysis. Others ignored restrictions out of necessity. Coordination between air defense, civil authorities, and military commands weakened. Silence protected nothing if it prevented response. Japan's leadership faced a dilemma with no solution. Modern war required communication. Industry required power. Transportation required signaling. To eliminate emissions entirely was to dismantle the nation itself. Yet to continue transmitting was to remain visible. This paradox eroded strategic confidence. In post-war interrogations, Japanese officers repeatedly described a sense of inevitability during the final months. Not inevitability of defeat alone, but inevitability of discovery. They believed that once a facility operated long enough, it would be found. Once a pattern existed, it would be exploited. The psychological effect extended beyond the military. Civil defense authorities struggled to reassure populations when air raid warnings offered no clear guidance. Shelters filled even when skies were silent. Anxiety spread not with the sound of engines, but with radio alerts themselves. For the Allies, the implications were clear. Electronic warfare, still a young concept, had proven decisive. Navigation aids, radar bombing, and signal intelligence had compressed distance, neutralized weather, and undermined concealment. What began as a technical advantage had become strategic dominance. This experience did not end with the war. Lessons drawn from the Pacific Air Campaign shaped post-war military planning worldwide. Air forces invested heavily in radar, guidance systems, and electronic countermeasures. The idea that control of the electromagnetic spectrum was as vital as control of airspace became doctrine. The Japanese experience stood as a warning. A modern nation could be heard before it could be seen. And once heard, it could be struck. As the war moved toward its final chapter, the legacy of those radio-guided bombs lingered, not only in ruins, but in the understanding that warfare had crossed a threshold. And that realization demanded reflection. The terror Japanese officers felt was not born from superstition. It came from recognition. They were witnessing the moment when war stepped beyond human senses, when sight, sound, and distance lost their authority, when decisions made in quiet rooms, transmissions sent, systems activated, power switched on, echoed outward in ways no one could fully control. Radio signals were never meant to betray cities. They were tools of coordination, progress, and modern command. But in the Second World War, those same signals became reference points for destruction. Not because the enemy was watching, but because the enemy was listening, measuring, calculating, aligning. What appeared as bombs following radio waves was, in truth, the disappearance of uncertainty. Once uncertainty vanished, defense collapsed inward. Camouflage failed. Night failed. Weather failed. The battlefield expanded into an invisible realm where advantage belonged to those who understood it first. This was not the loud revolution of tanks or the visible terror of massed fleets. It was quiet. It happened in laboratories, in antennas, in screens glowing faintly inside aircraft thousands of meters above the earth. Its effects were felt later on the ground, in the sudden precision of impact. The fear it produced was rational, because it signaled a future where survival depended not only on strength or courage, but on awareness of how deeply technology could reach. When the war ended, the bombs stopped falling, but the lesson remained. In modern conflict, silence is never empty. Signals are never neutral. And once war learns how to listen, it never forgets.